Welcome to the intersection of technology, cybersecurity, and society. Welcome to ITSP Magazine. You're listening to a new episode of Stories from Space podcast, where your host, Matthew Williams, examines the history of human spaceflight, the breakthroughs that revolutionized our understanding of the universe and our place in it, and the brave individuals who work tirelessly to advance the frontiers of our understanding. Knowledge is power, now more than ever.
The authors acknowledge that this podcast was recorded on the traditional, unceded lands of the Lekwungen peoples.
Hello, and welcome back to another episode of Stories from Space. I'm your host, Matt Williams, and today we're going to be picking up in our ongoing series of Settling the Solar System, or the Great Migration, how humanity could someday live on just about every astronomical body that orbits our sun. And so far, we've looked at how humanity could someday live on the Moon, on Mars, on Venus, on Mercury, within the asteroid belt, and on and around the largest moons orbiting Jupiter. Well, today we're going to be looking at Saturn's system of moons, otherwise known as the Cronians. And these include the moons Titan, Rhea, Iapetus, Dione, Tethys, Enceladus, and Mimas. So right off the bat, for those who listened to our previous episode on how we might settle on Jupiter's largest moons, you'll immediately notice that the list of candidates is significantly longer. Whereas Jupiter has 3 potential candidates, Europa, Ganymede, and Callisto, and there are doubts that some of these bodies could in fact be habitable in the long term due to Jupiter's powerful radiation and powerful magnetic field. The environment around Saturn is significantly more hospitable in terms of radiation, and so the list of candidates jumps from 3 to 7. In addition, the Saturn system boasts tremendous resources, much like Jupiter and its moons. But here, too, the more hospitable environment means that harvesting these resources and using them in order to create self-sustaining settlements there would be significantly easier. And though distance is a concern, it has been speculated that Saturn's system of moons could someday become the, quote, Persian Gulf of the solar system. And this is a direct quote from Robert Zubrin, the famed aerospace engineer and advocate for the exploration of Mars. And this quote comes directly from his book, Entering Space, Creating a Spacefaring Civilization. However, unlike the current Persian Gulf, which is a major exporter of fossil fuels to the entire world, Saturn and its system of moons would enable access to helium-3, which is an excellent fuel for fusion reactors. So in this respect, establishing a human foothold in the Saturn system would mean that the fusion era could truly begin. And coincidentally, this same fuel would allow for transits to and from Saturn, because in order to make the journey from Earth to the outer solar system in a reasonable amount of time will require things like nuclear propulsion systems, one of which is nuclear thermal, which relies on hydrogen or deuterium fuel, or possibly helium-3. And, as always, the concept is very time-honored and has been explored extensively in science fiction, which predates actual scientific proposals and research. However, the two are very much interrelated and co-inspired. One of the earliest known examples is Arthur C. Clarke's 1976 novel, Imperial Earth, where Titan, Saturn's largest moon, is home to a human settlement of 250,000 people, which plays a vital role in commerce, where hydrogen is taken from atmosphere Saturn and is used as the fuel for interplanetary travel. Another example is the series by Piers Anthony, Bio of a Space Tyrant, which was published between 1983 and 2001. And in these stories, Saturn's moons have been settled by various nations in a diaspora era, where humans have settled virtually every corner of the solar system. And Titan, in particular, has been settled by people from Japan, whereas other nations have established outposts in Saturn's atmosphere. And Fiasco, by famed science fiction author Stanislaw Lem, which was released in 1986, there's a sequence in the first few chapters where a character ends up frozen on the surface of Titan and is found and thought out several hundred years later. And in his 1997 novel Titan, Stephen Baxter has a plot where a NASA mission to Titan goes wrong and the crew must survive on the surface after crash landing. And then you have Kim Stanley Robinson, who references the Saturn system and its moons several times in both his Mars trilogy and his novel 2312. There are settlements on Titan and Iapetus, whereas in the Mars trilogy it's explained that nitrogen was imported from Titan in order to terraform Mars. And he also speaks in 2312 about the Enceladian biota, so the living microscopic alien organisms that live inside Enceladus. Consuming these biota is seen as a medicinal practice and something of a ritual among certain adventurous people. And of course, Ben Bova, who wrote an entire series of books on the solar system and human exploration thereof, known as the Grand Tour series. 2 novels, Saturn and Titan, were released in 2003 and 2006, and both center on the creation of human settlements in Saturn's system. Much like Jupiter, Saturn has been known to human astronomers for millennia. In fact, it's one of the few planets that's visible at night with the naked eye. However, it wasn't until the 17th century that astronomers began to observe Saturn's rings and moons, and unlike Jupiter, where its largest moons were all discovered by Galileo Galilei in 1610, it took several generations of astronomers between 1655 and the late 19th century before all of Saturn's largest moons were identified. And in keeping with classical Western naming conventions, all of the larger moons were named after the brothers and sisters of Saturn, the god of agriculture and the harvest in the Roman pantheon, which is the equivalent of Kronos in the Greek pantheon. And in the Greek pantheon, Kronos was the father of the Titans and the patriarchal god who gave birth to Zeus and the Olympians. And so, in 1655, when Christian Huygens discovered Saturn's largest moon, it earned the name Titan. A few years later, Giovanni Domenico Cassini discovered Rhea, Iapetus, Tethys, and Dion, all of which are named after other Titans in the pantheon. And between the 18th and 19th centuries, William Herschel, William Henry Pickering, and several other astronomers discovered the remaining larger satellites, including Mimas and Enceladus. And by the latest count, Saturn has 146 confirmed moons, though little over 50 of them have been formally named. And, as noted, the largest of these moons is Titan, which is about 1.5 times the size of our moon, and 1.8 times as massive. However, it has a lower density, which is indicative of a composition that's largely made of ice, which means that its gravity is slightly lower than the moon. Instead of 16.5% normal gravity, Titan's is around 13.8%. However, Titan has one very distinguishing feature which makes it a good candidate for habitability, and that is the fact that it is the only celestial body, aside from Earth, that has a dense nitrogen atmosphere. As to where it came from or how it was generated, scientists are still not sure. Also very fascinating is the fact that Titan has a lot of organic molecules in its atmosphere and on the surface in the form of methane, butane, ethane, and other hydrocarbons. What's more, these hydrocarbons have a cycle, which is very similar to Earth's water cycle, where methane exists in liquid form on the surface, and in fact Titan is well known for its methane lakes, especially around its northern hemisphere. And these include Kraken Mare, the largest, which measures an estimated 500,000 square kilometers, making it larger than the Caspian Sea on Earth. Other smaller ones include Ligeia, which has a surface area of 126,000 square kilometers. In any case, methane evaporates from these bodies and then forms methane clouds in the atmosphere, which then return liquid methane to the surface in the form of precipitation. So exactly as water behaves on Earth, methane behaves on Titan. And last but not least, Thanks to the Cassini probe and Huygens lander, which explored Saturn and its moons between 2004 and 2017, scientists also know that the surface of Titan, which is predominantly composed of water ice, is covered in a thick layer of hydrocarbons and organic molecules, and that it has this rich prebiotic chemistry going on. And all of this has led to speculation that perhaps life could exist on Titan in some exotic form. Because the basic building blocks are there, it's just a question of whether or not life could actually emerge and evolve under such cold conditions. And in the coming years, NASA hopes to investigate this possibility with the Dragonfly mission, which is a nuclear-powered quadcopter capable of vertical takeoff and landing, and it will be able to gather samples from the surface and from the lakes themselves in the hopes of finding not just organic molecules and prebiotic chemistry, but actual life, or at the very least, evidence of biosignatures, the kinds of processes or byproducts that come from living beings. In any case, if human beings were to attempt to settle in the Saturn system, Titan is considered the prime candidate, and aside from its abundant resource base and its proximity to Saturn, Titan's atmosphere is incredibly dense, roughly 1.5 times that of Earth, and it's predominantly composed of nitrogen gas. And given that there is no oxygen to speak of in the atmosphere, the methane and hydrocarbons are not flammable. You would never be able to get a fire going there, which makes them a perfectly safe potential resource, which could be used for everything: fuel cells and heating habitats, or as part of an export economy, which would be very useful for other planets where terraforming efforts are underway, particularly Mars, where super greenhouse gases are needed. And what's more, the atmospheric pressure means that habitats built on the surface, they would not be susceptible to decompression danger. Whereas on any other body where the atmosphere is thin or the body itself is airless, and this includes the Moon and Mars, the pressure differential between the interior of the habitat and the outside world, it makes decompression a very serious risk. In Titan's case, if a habitat breached, it wouldn't decompress at all. Rather, nitrogen, the exterior atmosphere, would begin leaking into the habitat, which is non-toxic. But trace amounts of methane and other hydrocarbons would get in too, so that would necessitate that people still practice good habitat discipline and patch any holes as soon as they appear. And while Titan's dense atmosphere, in addition to its distance from the sun, mean that very little solar radiation reaches the surface, that atmosphere also ensures that settlers are protected, that they're insulated against cosmic radiation. And as noted in a previous episode, how we would settle among Jupiter's moons, Jupiter's powerful magnetic field is a very serious radiation hazard for anyone hoping to settle on any of its innermost moons. But Saturn, on the other hand, is low radiation by comparison. So settlers in this system would not only have several moons upon which to settle, but a low radiation environment. So while pressurized suits and habitats would still be needed, and habitats would need to be heated and insulated against the outside cold, there would not be the need for so much radiation shielding on the surface. And in addition, a settlement on Titan would give humans access to Saturn's abundant helium-3, which, as Zubrin mentioned, would be the fuel for the new fusion economy. So this could be used to power reactors on Titan itself, as well as for export to power nuclear-powered spaceships, fusion reactors back on Earth, and other settled planets, and also for the nuclear propulsion spacecraft that will be needed to facilitate transport back and forth. And last but not least, carbon could be harvested from the local asteroids in the Saturn system in order to create graphene ribbon, which, according to current research, has the tensile strength to support a space elevator here on Earth. But on Titan, much like the Moon or Mars, where the gravity is lower, the graphene ribbons would be under much less stress and could accommodate heavier payloads, and these would facilitate, one or more of them, trips to and from the surface, bringing in new settlers and much-needed supplies, and exporting all kinds of resources for use elsewhere. including water ice, volatiles, nitrogen, and organic molecule fertilizers. Now, as for Jupiter's other moons, Rhea, Iapetus, Dione, Enceladus, and Mimas, all of these are airless bodies, which would mean that any habitats constructed on the surface would have to be airtight. But as with Titan, this could be done by, again, harvesting local asteroids and using the regolith and metals to 3D print structures on the surface, including domes, either a large dome to house an entire city-sized population, or smaller habitats connected across the surface. These settlements could be built in craters, with a dome enclosing the habitat and regolith used to create an insulating layer beneath. Another possibility, similar to settling on Europa or Ganymede, would be to build settlements within the ice sheet. There could very well be ice pockets in Enceladus and Saturn's other icy and airless moons. And as for creating livable conditions, the abundance of water ice and nitrogen works in our favor. Water ice could be harvested and disassociated to create oxygen gas, and combined with nitrogen gas from Titan's atmosphere to create breathable atmospheres with sufficient pressures inside the habitats. And the abundance of ammonia in the Saturn system could also be chemically converted for its nitrogen and hydrogen. So here again, you'd have a buffer gas for habitats on the one hand, and hydrogen gas to fashion propellant. And of course, as a final step, all these habitats would need a bioregenerative life support system. So plants, animals, trees, foliage, insects, bacteria, lichen, everything that's needed to create a self-sustaining life cycle would need to be introduced. Now, as for what's to be done about the gravity situation in all cases is comparable to that of Earth's moon, and so this would present long-term issues, perchance. And of course, this could be addressed with a number of solutions, one of which includes biologically engineering plants and organisms to survive in lower gravity. And as for humans, much the same could be attempted, but the easiest answer is to have rotating habitats in space. And these could be positioned in orbit of some of the moons, or they could be placed at the Jupiter-Sun Lagrange points, where they would be gravitationally stable, and these would rotate to impart simulated gravity, and people would periodically go to these places for the sake of gravity therapy. And of course, there's also gravity therapy that could happen in surface habitats, centrifuges, where people go to work out. So basically, there are solutions to every challenge. The advent of nuclear thermal and nuclear electric propulsion, for one, and similarly advanced concepts that rely on fusion and hydrogen fuel and helium-3. These would allow for spacecraft that could make the journey in a reasonable amount of time. This would lead to a large export economy, where Saturn is basically providing for the fuel needs of the entire system, as well as a lot of raw materials, which in many cases can be used to terraform planets like Mars and Venus. And of course, there would also be the potential for astrobiological research. As I mentioned, it has been speculated that there may be life on Titan's surface, possibly living in its lakes, possibly underground, because many of Saturn's largest moons also happen to be ocean worlds, which mean that they are composed predominantly of water and other volatiles, and they are differentiated between an icy surface and a core of silicate minerals and metal with a liquid ocean in between. And this is true of Titan, and it's also true of Enceladus, which the Cassini mission also studied in detail. And though it is Enceladus's smallest spherical moons, or the smallest moon that was able to undergo hydrostatic equilibrium, where it becomes spherical under the pressure of its own gravity, it is nevertheless famous for being one of the few geologically active satellites in the solar system. And this is due to, much like Jupiter's largest moons, tidal flexing in the interior, which is caused by interaction with Saturn's powerful gravity. And this is what powers its interior ocean, what allows it to maintain a warm water ocean just beneath the icy surface. And this was already realized when scientists examined data acquired by multiple missions that showed tiger stripes on its southern polar region. And these tiger stripes refer to a series of continuous parallel faults that are located around the area, and whereas the rest of the surface is generally white ice, these are teal-colored, just light blue-green. And during several flybys of the moon, the Cassini orbiter also spotted plumes coming from the southern polar region, which appeared to be emanating all the way from the deep interior. And after multiple studies were performed on all the data Cassini gathered, scientists concluded, yes, those plumes reach all the way to the core mantle boundary. And so if there's hydrothermal vents down there, which we have every reason to believe there are, and that's what's keeping the liquid ocean liquid, then those same vents are shooting that material out through the surface, and it contains silicate minerals, organic molecules, and as a result, scientists are very, very eager to send another mission, an Enceladus probe, to fly through those plumes and sample them and see if, in fact, there is biosignatures, actual signs of life. So here, too, if humans had settled in the Saturn system, we could study those plumes up close and in a very detailed way to determine whether or not Enceladus, in fact, had life inside of it, most likely in the form of microbes and simple life forms, single-celled bacteria, and what that would reveal about the origins of life in our solar system, much like finding evidence of life on Mars or life on Titan, would be absolutely staggering. However, this also raises some very serious ethical implications, and these constitute one of many challenges that would need to be addressed or overcome in advance before we can contemplate sending human beings to the Saturn system to settle and live. And as noted already, the first and most obvious challenge is distance. Much like with Jupiter or Mars, the distance between Earth and Saturn varies considerably depending upon whether or not the planet is at opposition or conjunction. Opposition refers to when Earth and Saturn are on the same side of the Sun, so at their closest, whereas conjunction is when they're on opposite sides of the Sun and farthest apart. So, when Saturn is at an opposition and Earth is closest to it, they are approximately 1.2 billion kilometers apart, or 746 million miles. And that's 8 times the distance between Earth and the Sun, so 8 astronomical units. But when Saturn is at a conjunction, Saturn is roughly 1.7 billion kilometers away, or 1 billion miles, or 11 AU. And this is a significant increase over the distance between Earth and Jupiter. However, Earth and Saturn are in opposition almost once a year, which presents much more favorable launch windows than Mars, which occur every 26 months. So while the distances would be greater, launch opportunities would be more common. Using conventional methods, though, a crewed mission could take as much as 30,000 days to reach the Saturn system, which is why, of course, nuclear propulsion systems are being considered. Now, based on current nuclear thermal or nuclear electric propulsion designs, which are being considered for Mars and offer the promise of making transits to Mars in about 90 days, it would still take over 1,000 days to reach Saturn, or 3 years. And this is simply not economical if we're hoping to establish permanent settlements there, as well as exporting resources and hauling them back. So more advanced concepts, such as plasma rockets, which are currently under research, would be needed to make these kinds of journeys. And these would fall under the heading of fusion thermal or fusion electric propulsion, which offers significantly higher propulsion and therefore shorter transits. There's also the issue of gravity, but as noted, that could be addressed with centrifuges and pinwheel stations, which could be built locally using in-situ resource utilization. The Saturn system is nothing if not abundant in terms of mineral resources, silica resources, and basic elements like carbon, which could be fashioned into supermaterials. So the problem of lower gravity and the long-term physiological effects could be addressed. It's just that it would require significant engineering and wouldn't be cheap. And finally, there is the issue of indigenous life forms. If the Cronian system has indigenous life forms. If there's microbes or more complex creatures living on Titan within Enceladus or Mimas, Iapetus, and Dion, which are also considered to be ocean moons, then we have to be cognizant of the fact that establishing human settlements there, mining for ice and volatiles, attempting to study their interior oceans and look for life, that this could have a profound impact on the life forms themselves. We may end up contaminating entire biospheres or causing the extinction of the entire biome inside any one of these moons. And so, once again, this raises the question, do we have a right to do this? What are the ethics of settling on bodies that are not lifeless, even if they do lack an atmosphere, but may in fact support indigenous life that is, even though it's simple and microbial, is nevertheless unique and most likely completely unrelated to life on Earth. But then again, we may find that through resurfacing events or what have you, biological material was exchanged between the outer solar system and the inner solar system, which means that these life forms could be genetically related to human beings. And that too raises ethical implications, whether or not the life is related to us. And this applies for potential life forms found on Mars, found within Europa or Ganymede, or anywhere else. Finding that life and being able to research it could confirm theories like panspermia, which indicates that life is distributed throughout the cosmos on asteroids or rogue planets or bodies traveling between solar systems. And if that is in fact the case, then that does have an effect on the ethical landscape. But if the life is not related to us, if it is truly alien, destroying it, however accidentally, would still be an immeasurable loss and a very severe crime. So great care must be taken to avoid its destruction. And again, if it is related to Earth, however distantly, it also needs to be protected. Great care needs to be taken so that it can be researched safely, so that we can learn about the evolution of life within our solar system without doing harm. As always, the campsite rule applies. Leave the place better than you found it. So that means living sustainably with the local environment rather than strip mining it or ruining it for our own selfish purposes. That brings us up to Saturn in our grand tour of the Great Migration and how human beings could settle throughout the solar system. Next time we will discuss Uranus and its systems of moons, as well as Neptune and Triton, and the outer solar system, including Pluto, Charon, and other dwarf planets, or minor planets, or just Kuiper Belt objects as they're known. In addition, we'll have more episodes exploring other proposed resolutions to the Fermi paradox, episodes dedicated to how we might terraform the different bodies of the solar system, and interviews with scientists and principal investigators who are going to be playing a key role in some of the upcoming missions to Mars and the outer solar system in the coming years. In the meantime, thank you for listening. I'm Matt Williams, and this has been Stories from Space.
We hope you enjoyed this episode of Stories from Space podcast with Matthew Williams. If you learned something new and this podcast made you think, then share itspmagazine.com with your friends, family, and colleagues. If you represent a company and wish to associate your brand with our conversations, sponsor one or more of our podcast channels. We hope you will come back for more stories and follow us on our journey. You can always find us at the intersection of technology, cybersecurity, and society.